Okay, welcome to the notes on midpoint and distance. So if you'll turn to page 7 in your notebook, okay, a little life lesson right here about don't say you'll never use something, okay. Page 7, midpoint. And midpoint means halfway between 2 points, but what if it's on a graph and you got to figure it out? Some people say, well, you can just count. Well, you can't count when they're diagonal. If pieces are slanted like that, you're not allowed to count that space because this does not have a length of 1. And if it's like tilted a little bit or tilted a lot, it's not going to be the same space. The only things that are 1 on a graph will be like straight across or straight up and down. So those are the ones you can count. But you could, the way you're going to do it is the formula. So the distance, the midpoint formula, you got to find halfway between the x's and halfway between the y's. And in that case, we're saying here's an endpoint with x, y, and here's an endpoint with x, y. Every time you have, what color here? Every time you've got a point, you've got an x and a y ordered pair. And then you've got another x and a y ordered pair down here. So we want to find halfway between them. We got to say, well, if the x's had, let's say, a space of 10 all the way between them, then halfway would be 10 divided by 2. So what you're going to do is you're going to put your x's together, add them up, and divide by 2, and then put the y's together and divide by 2. So midpoint is halfway, so always think of it as half. And that's the one you're going to be dividing by 2. All right. So if we've got a midpoint, sometimes they'll give it to you on a graph. Sometimes they'll just list the points. Then you need to think about what are my points up here. And I always try to label mine. This is x and y, and this is x and y. So I don't get them confused when filling them in. X and x go together. You're adding the x's together. So if I start my first formula, I'm going to pull in those 2 x's. Doesn't matter which one goes first, they're being added up, so you can put either one first. Add up the top, you can use a calculator, and then divide by 2, you get -6. So your first section of your answer is -6. And then the second part, take just the y's, -3, 13, and plug them in, add them up, and divide by 2, you get 5. So halfway between them is 5. Easy enough. And hopefully you did that formula back in algebra. Yeah, this one's on your notes if you want to write them. But it's all in there. Same kind of math right there. All right. So what if you're missing an endpoint? So I'm giving you the midpoint. That's right there. And I've got one endpoint right here. This other endpoint, I don't know. Well, if it's dealing with midpoint, it's a midpoint problem, because I gave you a midpoint, then you're still going to set it up with that formula that you had before. Here are the points. That's the midpoint, -3, 5, and that's one of your endpoints, and the other one you don't know. You're going to use that same exact formula, but this time, one of the x's, let's start with x here, and an x here, you don't know one of them. But what you do know, see, there's the one you don't know. What you do know is now your answer would have been the midpoint. You already know that is -3. So that's going to get filled in. So now it's the same formula. It's just you got to work it with a little algebra twist to it. We want to get x by itself, but this is a fraction. It would be easy if this wasn't a fraction. Well, let's make it not a fraction anymore. It's being divided by 2. How do you get rid of dividing by 2? Multiply by a regular 2 out here, and it'll cancel out. Come over here, do the same thing, times a regular 2. All right, that comes up there. All right, what's left? -2 plus x. What's left over here? -6. And now it's an easy problem. Move your -2 plus 2 plus 2, and you get, it's kind of slow, -4. Okay, so yeah, first endpoint has a x value of -4. You try it for the y. Do the same kind of setup. See if you can get it. Stop the video a minute and try it. So this is a good little explanation on one, like, you could see on ACT. That's the level they would do it. If you're lucky, they might put you a regular midpoint problem on there, but chances are, if you had a midpoint, they're going to give it a little twist like that. But it's the same exact formula. Okay, distance formula is next. And there's some problems on the worksheet that I wanted you to do for midpoint, but you can get to them later. This is the distance formula. Yeah, okay, this is back on page 6. And in algebra, you were taught how to, plug in the same way we did with the midpoint, but it's got all this other mess going with it. One good thing about geometry is when you get to the distance problems that are graphed, you can work them as a geometry problem instead of just a regular old distance problem. So back on page 6, they're saying that Don lives 3 blocks east of Descartes Avenue, and these are mathematicians' names. So he's over here 3 and 5 blocks north of Elm. So he's at 35. Excuse me, not Corona. Alright, so that's Don. Alright, his friend Frida lives 7 blocks east and 2 blocks north of Elm Street. So 7 and 2. 2 blocks north of Elm, so come up 2 from him. Alright, that's Frida. Alright, and we want to know the distance between their 2 houses. So you could do the distance formula like we showed a minute ago, or you can think about this. You can't just count it, but normally if these were like, regular streets or something, you wouldn't go, through somebody's yard or something to get there. You'd have to go down some regular perpendicular streets. So what they're saying on this is to make Bert's house, and Bert, I think he's on another page, but I can't go back and forth. So Bert lives right here at 3, 2, 2, 3. Oh yeah, 3, 2. All right, so what we want to do, in other words, is we want to come straight across from F, Frida, and stop at Bert and go straight up to Don's house. In other words, sort of like rise and run. Remember how you used to do that idea? Now what shape do we see? A triangle. Guess what? This side of the triangle is lined up. You got 1, 2, 3, 4 spaces. That has a distance of 4 blocks, whatever. 1, 2, 3 going up. Can you now find this side? You sure can. A whole lot easier than doing the now. And so there's your examples of it. All right. Distance formula. Now, how it ties in to the distance formula. Remember this. All right. Bert's house to Frida's house. The distance between Bert and Frida, 7 to 3. Straight up and down, 7 to 3. All right. I think no, straight across from 7 to. Frida was at 7 and Bert was at 3. All right. From Don to Bert, Don was at 5 and Bert was at 2. This was vertically, and you get that. And so what we're doing, and they kind of left this off on this graph, they should have squared the distance as well. Everything's getting squared. That the way they do this is so you don't end up with negative numbers. 7 minus 3 is 4. 5 minus 2 is 3. What is this looking like with these little squares? See them on there? Pythagorean theorem. So then you square it, 16, square it, you get 9. This is already squared. So 25 is d squared. What do? Square root it, and you get 5 for d. But when you look back up here at this first row, this is basically the distance formula. It's just instead of d being squared, they just got the regular d. And so that means the other squares have to disappear. That means it's the square root of all that. 7 minus 3. Then it gets squared to make the positives. It's just a bunch of little algebra tricks up in there. Minus 5 minus 2. So that is the distance formula is Pythagorean theorem when you get down to it, looking like that on the graph. But which one's easier? Pythagorean theorem. Okay? The formula still has to be used from time to time. Alright, so let's see if I did it on this one. That's just